Over to you, Enrico.
Thank you, Bindu, and good afternoon to everybody. I may run into connectivity problems, so you forgive me if I switch off the camera, but probably it's better that we focalize on the presentation. So, thank you for the opportunity to talk about semantic. Next slide, please. And one thing that I think it should have become clear to everybody is that, as also mentioned by Bindu before, is the fact that the environment in which put application is really complex. There are hundreds of solutions which are in some way leaded and some level of standardization, some level of openness, and really much more which are fully proprietary. So that's important to understand that oneM2M is trying to put these things together. I think that from the previous presentation, if we go to the next slide, please, we can have understood that oneM2M is a framework designed to exchange and share data between different solutions, and is mainly a sort of interworking framework. Now we focalize on the additional steps. Once we have exchanged the data, we have to understand what are these data and exchange the understanding, the meaning of this data. Next slide, please. If we look at this simple example, which is made with OCF, you will have something which runs a solution like OCF, which arrives to what has been mentioned before in the architecture of interworking to the border of a oneM2M system, where this is essentially interworked and put in common. So the same data can be exchanged between different parties independently from the protocols that they are using. It can be natively oneM2M, but oneM2M is designed exactly to integrate also the diversity of a different solution. Now, the question is, if you look at the right side up, which semantic is used between the oneM2M system? Now, we can do it very abruptly and use the OCF data model and transport them. But in this case, you require that the two parties at the border talk the same system. So in this example, you need an application which is OCF. But there is more. If I map the semantic, if I put it, the information in some, adding some information will allow me to understand the meaning of the data, I can arrive to the final goal, which is exactly to have one application which talks one specific protocol and one specific semantic to talk with another application which talks another protocol and another semantic. The protocol is taking directly part in oneM2M platform. The semantic are a set of, let me say, specifications which are included at least to certain parts to oneM2M, which are not part directly of the platform except support for this specification, but is more some lines of that I have to follow while I make this kind of interworking to assure semantic interoperability. We go to the next slide, please. What essentially we do in the platform is to include in certain different feature which supports the semantic information. Even from the first release, we had the possibility to include specific names, labels, but also very important to link each data with a specific semantic. So I can get from a description of this semantic. That means that to a certain extent, the data are tagged. In release 2, we had really for a description of ontology, and then go in the release 3 and 4 to have more expansion defining what is called a smart device template, which is used especially device side to define the functionality of some model and try to reuse these models. take into account that you are not obliged, you can still, with the function that you see in this slide, to exchange information in your own way, but then you have, as the example that I mentioned before, you need that the other party understand that, or at least is able to translate that. Or you can do something more, which is using something like the smart device template, which allows to define common models for objects. Now, if we go to the next slide, please. What we have is exactly a sort of effort in mapping the vertical in ontology into what is called oneM2M based ontology, which means it's a common model which is used in oneM2M. That's exactly the way in which we in oneM2M is trying to taking care of the ontology. At the interworking, apply some set of rules in mapping your own data model, your own informational model, into a common model, which allows you to exchange some information. Now, going next slide. Just waiting that appears on my screen. That's exactly the ontology, which allows you to annotate and to describe. So oneM2M allows to annotate. oneM2M ontology allows to describe models, and it's directly mapped on the SDT model that I mentioned before, but also on another very important model for ontologies, which is called SAREF, Smart Application Reference Ontology, which I will spend a little bit more word a little bit later in this presentation. That's a model that is called a generic interworking, which allows you to interwork with whatever externally. And if you have a common ontology defined or a common way of mapping your ontology, you can reach the semantic interoperability objective. Next slide, please. This is an example which has been done some time ago, where we have, a few years ago, where we have a car which was talking with an agricultural machine. The objective of the demonstration was relatively simple, was essentially when the agricultural machines moves on the road from the fields, is a slow machine respect to the car. So the cars are alerted that this machine is going to enter and there is a slow vehicle running on the road till the vehicle is out of the road. Now, why you tend to present these things is, apart from the fact that the demonstration itself was nice, but one of the important things is that it can exalt the relevance of the semantic interoperability. In the car and the tractor, we're using the same base protocol for communicating with cars. They are only using isobus, which is a common standard for cars. So to a certain extent, they had a common model, a common protocol on below. But the point is that the semantic used by the cars is very different by the semantic used by the agricultural machines. AEF is the measure of association in agricultural machines. That's exactly where oneM2M was put in the middle. Not so much to facilitate the communication itself in terms of exchange of data, but because was needed something in the middle which was able to perform a sort of a conversion of a semantic model into common model. So it can be used by agricultural machine, but cars, but can be used also by cities or road managers to get the information. And that was the value of oneM2M in this specific use case. Go next slide, please. That's here you find an example of a oneM2M based ontology model in abstract. This is the base ontology. And if we go to next slide, you find an example of an instantiation of the same model into the real object. A couple of slides just to provide you an example what it means. What is theoretical becomes something practical when you map this object into services, into aspects like temperature. So as some functionalities, as some properties, as some services, is part of something else. And that's the kind of model which is used to build in core using the base ontology. Going next slide, please. I anticipated before that there is SAREF. SAREF is an attempt to derive the commonalities between different existing ontologies. In reality, in the world, a lot of people, everyone is using protocol, is using ontology. Sometimes even they don't call it ontologies. But de facto, when you define a data model, you start to describe objects and assume that object has some characteristics, some function, offer some services, etc. So de facto, what's happened is that whatever in the world is used to be expressed or to be communicated during communication using ontologies, and they don't realize they are ontologies. SAREF is trying to get this word of existing thing and try to remap and define what is in common and define the commonalities. I'm used to use this example. Things to a simple switch and a light in a room or a light in a panel. Some people call it the switch, some other call it a flip-flop. For other people is a relay. For other, but at the very end is an object which switch on and switch off lights. So independently how you call it, what kind of protocol you're using, what kind of semantic model you're using, is the concept behind is I'm able to switch on a light or switch on in general, let me say. And there are no reason why two systems which are talking different protocols and talking different semantic cannot do an action which are both common to do in collaboration. And that's exactly the concept of SAREF. Going next slide, please. What we have is exactly this model. SAREF is essentially getting all the vertical models and group them by sector, having, for example, the example of a common feature for energy, common feature for building, common feature for agriculture, and try to remap that on the general base ontology of oneM2M, because the core SAREF, the SAREF core is exactly equivalent to the general base ontology of oneM2M. So the result of that is that you have a three-level model. The first level is the communication framework, which is oneM2M, which allows you to perform data sharing. The semantic support, which is based on oneM2M due to the base ontology and the data annotation. And then the vertical ontologies, where you need to do something different. There are SDAT, which uses for devices, trying to define common models for all the devices. This approach of SAREF is trying to derive the existing ontology and find the commonalities without forcing them to adapt to a single model. Go next slide, please. That's currently where we are in SAREF. There are several sectors which have been already included. The SAREF core is a common, which is common for all the sector. The energy is our addition, which are extensions which are typical of energy sector. Then we have the building environment, smart cities, industry and manufacturers, smart agriculture, automotive, e-health, aging well, wearable, smart water, and smart lift. Some of them are very complete, like the energy building. The smart lift is very complete because it's been developed with the industries which are working on that. Some others are partial, or because we really need more input, like in the automotive, where we need, for example, more input, or because are so, let me say, extensive that we were not able to include all the ontologies or the major ontology available. For all the smart cities has a very huge number of ontology included, typical of a smart city environment, but is so, let me say, big that we were able only to probably to do a part of what can be the overall environment. Anyhow, this work is still in progress, trying to enlarge the things. If we go to the next slide, one thing that is important is that the work has been done by experts in the ETSI environment from contacting the different industries. Now there is an open portal active where the stakeholder can provide their own semantic input to the SAREF portal. Then currently in Smart2M, we are in the process of transforming them all in specification, but we are also started a discussion, and probably we start the discussion a little bit more for release 5 to transfer all this work in oneM2M, because it's already strictly related by oneM2M with oneM2M. So one possibility is exactly to continue this work of SAREF in oneM2M. Take into account that anyhow the open portal is very important, because it means that if you have a solution with your own protocol, so you are an association which has its own solution, you can go on the portal and try to build a new extension for your sector, or to upgrade the existing extension in the sector that you have seen before. Next slide, please. This is another example which has been implemented, which is called demand-side flexibilities. So essentially, the ability to control the grid for the power in case of lack of power, a controller can really modify or switch off some activity, some parts of the work, some part of a network, or some device in the network, as we see in the next slides. And that was one example which has been used with using oneM2M and SAREF. And next slide, please. This was also a very interesting demo, because there were, and it's even a little bit more than a demo, because the association which are behind that have really implemented in their products. You know that the dishwasher, washing machines, in general, the white goods in the house are really evolving, and evolving with additional feature and connectivity. Now the 10th year that has been implemented, and luckily has been also absorbed by the protocol of some of the major vendors of this kind of goods, white goods, at least in Europe, is that essentially, it's easier for me to describe the demo. You have a controller of one brand, which is able to control, of course, all the machine of his own brand, but also machines of other brands, and is also able to talk with a grid city control. So some information are really shared independently from the brand of the controller of the machine, like how much you are consuming. And another very useful information is that if I can stop you in a certain phase, so if there is a lack of power in an area, the controller of the city can really contact all the controller in the house of each of the devices, and having a good picture of what can be switched off and switched on. Just to clarify, there are still a big respect of the proprietary solution. For example, if you are a dishwasher, probably you have some programs you know by your controller, because are typical of your brand, that make the difference with respect to the other competitors. But some information like how much power, how many revolution per minute, or for example, I can be switched off or switched on remotely because it doesn't interfere in my cycle of washing, are really information which are common to all the dishwasher. So why we cannot use this information and share it? Next slide, please. Okay, this is just to show what is basically the task of oneM2M, taking care of the developments. In our implementation in Telecom Italia, we very rarely have oneM2M devices or native devices. But we have all the applications which are oneM2M, and all the devices of the different brands are talking using oneM2M as an interworking framework. So we use it to integrate the diversity. Of course, there is the good effect that after some use of that, certain number of providers that we were in contact decide to go natively oneM2M because it was easier for them. And that was for us very good and very positive, because it means that they got the benefit of sharing the things, sharing the data, sharing the model, sharing communication, and try to compete on the services that they are offering and on the platform offering. Next slide, please. Essentially, this concludes my presentation. So thank you very much for listening to me. And I'm available for questions, even offline after the meeting. You have my email. You are free to contact me. Thank you.
Thank you very much, Enrico, for that presentation.